Now the next function of the kidney we want to consider is the fact that the kidney is controlling red cell mass and therefore the amount of oxygen that the blood is able to carry. So again, we can think about a kidney. As you know, the outer part of the kidney is the cortex, the inner part the medulla. Now situated in the lower part of the cortex, there are a group of specialized fibroblast type cells, and these are called repos cells. Now this stands for renal EPO producing oxygen sensing cells. And this will make a bit more sense in a minute, but renal EPO producing oxygen sensing cells. Now these cells are sensitive to the amount of oxygen in the blood flowing through the kidney. So there's a good blood supply to the kidney in the renal artery. That blood is perfusing the kidney. And these repos cells are detecting the amount of oxygen in that blood. Now, if the oxygen levels as detected by the repos cells reduces, then these repos cells respond by producing erythropoietin. Erythropoietin, and this is a hormone. It's a glycoprotein. It contains protein and carbohydrate components. So the lower the level of oxygen in the blood going through the kidney, the more erythropoietin is going to be produced. And erythropoietin is abbreviated EPO. The abbreviation is EPO. So here we see renal EPO producing oxygen sensing cells. So these fibroblast type cells are detecting the amount of oxygen in the lower part of the renal cortex. It's actually quite a good place to have it really when you think about it, because the kidney's got a very large blood supply, over a litre of blood per minute in a healthy adult going to the two kidneys. Over 20% of cardiac output is going to the kidneys so the blood can be cleaned and filtered. So it's a good place to put oxygen sensors because of the large blood supply. So the oxygen level drops. If that happens, erythropoietin is produced. And because it's an endocrine hormone, it's going to circulate, and the erythropoietin circulates in the blood to the red bone marrow. It goes to the red bone marrow. Now, as you probably know, there's red bone marrow in the flat bones like the sternum and the ribs, the skull, the flat bones of the pelvis, and also there's red bone marrow in the ends of the long bones. So here we have a long bone, and in the end of the long bone we've got the red bone marrow. So here we have red bone marrow in the end of the long bone. And the red bone marrow contains stem cells that are responsible for the production of the red blood cells, the erythrocytes. And the erythropoietin circulates to the red bone marrow, and there it stimulates the stem cells to divide to produce more erythrocytes. So the erythropoietin is stimulating the process of erythropoiesis. So erythropoiesis is the production of red blood cells as stimulated by erythropoietin. So the increased erythropoiesis is going to result in the production of more red blood cells, more erythrocytes. There's going to be more erythrocytes. Now, of course, the erythrocytes are going to carry oxygen, and they're going to circulate to the kidney, They're going to circulate to the repos cells in the adrenal cortex, these fibroblast-like renal EPO producing and oxygen sensing cells. They're going to detect the increased amount of oxygen carried by the increased numbers of erythrocytes. And when they detect that, when they detect increased amounts of oxygen, they're going to reduce the amount of erythropoietin that is produced. If you reduce the amount of erythropoietin, that's going to reduce the stimulation of erythropoiesis, so less cells will be produced. So the body, via this erythropoietin, erythropoiesis, erythrocyte mechanism, is constantly adjusting the red cell mass. So we have just the right hematocrit. We don't want the blood to be too thick, we don't want it to be too thin. We want the blood to carry the right amount of oxygen. So more red blood cells detected carrying more oxygen, that's detected there, and the whole process is controlled by producing more or less erythropoietin. And this is very useful for patients who have renal failure. So in renal failure, the blood supply or the blood flow through the kidney is often reduced, and these patients can't produce their own erythropoietin. Now, when I was young, we used to give these patients blood transfusions. But then when erythropoietin became available, it's so much easier. You just give them an injection of EPO, the pharmaceutical form of erythropoietin, and their red bone marrow will produce their own red cells, therefore reversing the anemia of chronic renal failure. So excellent news for patients who have renal failure. EPO is now available. Unfortunately, some people have abused EPO and have taken it to increase their red cell mass, to increase their aerobic athletic capacity, which of course is cheating. But it has happened, and people have used this to cheat in athletic competition, which is unfortunate. So there we are, another function of the kidney, controlling red cell mass and the amount of oxygen carried by the blood.